So now we're going to talk about three very special limits. And I'm not going to go into a whole lot of detail about these. I'm just going to write them down. The limit as x goes to 0 of sine of x over x is 1. The limit as x goes to 0, 1 minus cosine x over x is 0. And finally, the limit as x goes to 0 of 1 plus x to the power 1 divided by x is e. So these three limits are, like it says, they're special. You will see them again. These limits do pop up a whole lot. In particular, you'll probably see them if you go on and take Calculus 2. They're frequently ones that are seen a whole lot. So what we're going to focus on is, now that we know these limits, let's see if we can find some other limits. We can use these to help us compute some other ones. Find the limit. The limit as x goes to 0, tangent of x over x. So the first thing we're going to do is plug in 0 and see what we get. Tangent of 0 over 0. What do I get? I get 0 over 0. This is called the indeterminate form. Because from this form, we can't tell what the limit is. We can't determine what the limit would be. So we're going to have to think about this one a little bit differently. We can't just use direct substitution here. Well, what I can do is I see this function tangent of x. I could think of that as being sine over cosine and then if I rearrange my fractions here, I move some stuff around, this would be sine of x over x times 1 over cosine x. And now I can split this limit up into the two pieces. Sine of x over x times the limit of 1 over cosine x. And now what happens when I plug in, so this first limit right here, this is one of our special limits. If you look back at the list, this limit is 1. And now if I plug in 0, I'll get 1 over cosine of 0, which is 1. So this is 1 times 1, or just 1. Let's do one more. Let's look at the following limit. Let's find the limit. The limit as x goes to 0, sine of 4x over x. This limit, it almost looks like that special first limit, but we've got kind of a problem here because this inside 4x and this denominator don't match. So what I'm going to do is I'm going to multiply top and bottom by 4. So I'm multiplying by 4 over 4, which means I'm multiplying by 1. I haven't changed anything. But now, what that's going to allow me to do, I can move. I'm going to pull this, so let me not do too much at once. I'm going to move this 4 there and over here. And now I'm going to pull this scalar out in front of the limit. So I'm getting 4 times the limit as x goes to 0 of sine of 4x over 4x. And now what we're going to do is we're going to relabel. I'm going to use a different variable. I'm going to replace 4x with a different letter. Let's call it y. Okay, so now I'm getting 4. I'm going to leave a space and fill in the limit in just a second. This will be sine of y over y. And then, so look at our limit before, x goes to 0. If x goes to 0, what happens to y? Well, y has to go to 0 as well. So this would be the limit as y goes to 0. And so now this part matches perfectly with our first special limit. Just I have y's instead of x's. So this limit would be equal to 1 according to our special limits. So overall, this limit would be 4.